Hi there, this is Nick broadcasting on the Get Me Off Grid video blog, and something interesting has happened with my online research, especially on the subject of hydrogen. I'm sure you're quite aware, being on YouTube, there's quite a few people who are attempting to make large quantities of hydrogen using electrolysis as a method, and thus to, of course, try and boost the fuel efficiency of their vehicles and so on and so forth. And there's a lot of controversy about this as to whether it's really and truly an efficient use of the electrical energy, and indeed whether it's actually using up more fuel, more of your diesel or petrol fuel, in order to create the hydrogen gas, and is therefore an inefficient reaction. What I've come across when doing a bit more internet research is another video and another subject. This is the production of hydrogen chemically, again using things which are probably readily available to the vast majority of people. The ingredients for this particular chemical reaction are aluminium foil, hot water, and washing soda. Apparently there is a chemical reaction between the surface of the aluminium as well as the base chemical, namely the sodium carbonate, which is in the water itself, namely the actual washing soda. And the end result is that large quantities of hydrogen gas are being produced. I'm going to link you to a video about this. And this particular video has a very interesting comment section. Now, I myself have not yet experimented with this, but I did have a hypothesis that if you did go off-grid and you happen to get yourself lots of washing soda, which is quite cheap, as well as lots of aluminium foil, which you can probably also get again at your pound shop or dollar store quite affordably. If you were to design something which you had gained from, or the inspiration for which you'd gained from the various HHO experimenters here on the internet, including gas capture devices, something to protect you against flashbacks, for instance, or maybe a scrubber to dry the gas, and so on and so forth, would you actually have a non-electrical means of very affordable hydrogen production which you could then use for cooking? I mean, this is still very hypothetical. I myself have not actually experimented with this, but I'll definitely link you to a video, and I would strongly recommend all of you watch the video and go through the comment section, because essentially it's really rather fascinating about the chemical reaction and how it actually occurs. And what I'm going to do is actually to start experimenting using aluminium foil, the cheapest I can lay my hands on, as well as washing soda, the cheapest I can lay my hands on, to see whether I can produce hydrogen very cost effectively, and then eventually to design something which could be used for chemical hydrogen production. I would of course then have to do some research into how one disposes of the wastewater, which will contain all kinds of nasty chemicals and various derivatives of the aluminium and the chemicals in the washing soda, and of course the water itself. And that could be another issue basically. But essentially we could still see what happens, and we can see whether this could be another form of off-grid energy generation technology which we essentially could use for the purposes of cooking. I don't think we could use it for heating because of the quantities of gas produced, the quantity of sodium carbonate or washing soda we'd actually have to lay our hands on, as well as the quantity of aluminium that we would also have to basically get our grubby little mitts on. And also how on earth would we dispose of the waste water, because that's going to be a big issue. I don't think you'd want to put it down the drain, because although you might want to get rid of it one way or another, you certainly wouldn't want to basically put it down the drain. I mean, there's environmental implications, there's agricultural and horticultural implications, there's all kinds of issues which can occur when you take like heavy metals and all the rest of that and just dispose of them in that way. So I think that this particular video I'm linking to raises some interesting questions which are important, but it doesn't necessarily provide us with the answers at this present point in time.